So if I look at Avogadro's number, uh, this particular number is very helpful in chemistry. Let's take a look at how that is. So this number is a standard quantity. Okay, it's a standard quantity called Avogadro's number, much like the word dozen, gross, or ream is. So every time you hear the word dozen, you know automatically that that means 12. And a gross, you may actually not know that one. That's not one that's as commonly known, but that's 144. And a ream, do you know how much is in a ream of paper? Okay, it's 500 sheets of paper in each ream. Okay, now for Avogadro's number, this standard unit is 6.02 times 10 to the 23rd power. Okay, or 602 sextillion. Okay, that's a lot. That's a lot of zeros there. That's a lot. Now, this number is not very practical with things that we can see. Just to kind of give you an example, 18.01 grams of water has 602 sextillion H2O molecules in it, or 6.02 times 10 to the 23rd power, or a mole. Okay, so 18.01 grams of H2O is basically a mole of water molecules. Okay, so there's that many H2O molecules in 18 grams of water. So a mole is the amount of substance that contains as many entities as there are atoms in exactly 12 grams of carbon-12 isotope. Okay, so what does that mean? So if I look at 12.01 grams of carbon, okay, so if I were to lay out 12.01 grams of carbon in front of me, I would know exactly how many atoms of carbon there are. There's 6.02 times 10 to the 23 atoms of carbon in 12 grams. And that's exactly what this means. And this is equal to a mole. So 1 mole, which is 6.02 times 10 to the 23, 1 mole equals that number, would equal 12 grams of carbon. So you can see that in chemistry, this number does have a lot of practical use, because when I'm dealing with atoms, I'm dealing with incredibly tiny things. And in order for me to be able to work with these things, I need to have a number, a standard unit that's gonna be helpful for me in converting grams to moles in chemical reactions. Okay, but this number is not very practical for me when it comes to things that are large. Like for example, a dozen donuts, easy, that's 12, right? Well, what if I were to have a mole of donuts? If I were to have a mole of donuts, that would be enough donuts to cover the entire Earth and create layers of donuts 5 miles high for the entire Earth. That's a lot. So as you can see, the enormity, the mass of this number is not very practical for me when dealing with large objects. Or if I were to have a mole of basketballs, that would be enough to make an entire new Earth. Crazy, huh? Well, here's one. A mole of dollars. If I gave you a mole of dollars and you spent $1 million a day for 100 years until you died, we would still have 99.9% of that money left over. So this is an enormous amount of, an enormous quantity, which again does not have much practical use for us other than in chemistry when we're dealing with tiny little things. So how does this number 12.01 come into play with this number? Well, 1 mole of carbon, which is 6.02 times 10 to the 23rd power, is 12.01 grams. 1 mole of iron is 55.85 grams. And 1 mole of sodium is 22.9 grams. So we need to deal with large numbers in order to get enough of this substance, a quantity large enough that we can work with in the lab. So this is where the mole comes into play. So 1 mole of each of these is that many particles or elements involved. Okay? Otherwise, we'd be dealing with numbers that are way too small for us, or quantities that are way too small and not practical enough for us to work in a lab. So this number, Avogadro's number, this idea was developed by a scientist named Amadeo Avogadro. He came up with this idea in 1811 and was largely dismissed by the scientific community. Up until 1909, where Jean Pirenne, a French scientist, used his number to win a Nobel Prize in 1926. And Jean Pirenne actually he recommended that number, since Avogadro's number was so instrumental in him winning the Nobel Prize, he recommended that number be named after him. And so we call that Avogadro's constant now, or Avogadro's number, which equals a mole, which equals 6.2 times 10 to the 23rd power particles of anything involved. Okay, so if I'm talking about a dozen carrots, you know I'm talking about 12 carrots. If I'm talking about a mole of carrots, then you know I'm talking about an enormous amount of carrots. But of course I wouldn't use this number with carrots because again, that goes out of the realm of practicality for us. Okay, so that does it for the introduction to Avogadro's number, or the mole. And in the next videos, we're going to be working out examples in which we actually use the mole, and you can see how it applies to chemistry and the types of problems that we'll be seeing in labs and in problems in your textbook. All right, good luck in your study.